Hello, eighth grade students. Today I'm not going to be here in the morning, so I'm going to record what I want you guys to be doing for today. Your teacher will pause the video for you to get things done and start it back up when you are finished. So, first of all, I think I got done with this page here with my first hour students, but probably not my second hour. I will finish questions 5 through 7 or 5 through 8 with you in second hour tomorrow. So for now, you can go ahead and just skip that. So, what I want you to do next is go to a new page and you can go ahead and write the title up here at the top. So investigation 2.1 air pressure inquiry. Now, if you look in your tray, you are going to see these notes here. So you are not going to have to write these notes. So you can go ahead and find these notes and glue them into your notebook after you write down the title. So again, look in your tray. You should see a piece of paper that has these notes on it. I'm going to have your teacher pause the video here to let everybody go ahead and get that written in at the top and glue this in. Okay, so I'm assuming that you have this glued in. I just want to read through this here and have you do a couple things. So it says in both systems, meaning the systems we're talking about the syringe activity and the plastic bottle air pressure indicator that we used yesterday. Those are the systems that I'm talking about. So in both systems, we showed that the volume of air can be changed, which then changes the pressure. Okay, so the volume of air can be changed, which changes the pressure. If you decrease your volume, meaning you give it smaller space to take up, then your pressure becomes higher and molecules and particles in there move faster. Okay. So when you decrease your volume and put it in smaller space, they're moving around faster and they have higher pressure. But if you increase your volume or give it a larger space, like when you let the syringe pull it back, or when you let the bottle go, then you lower the pressure and the molecules move slower. And I think I talked about this with second hour yesterday, and well, probably both of you, but I just want to reiterate this. The number of air particles is still the same in both cases. Assuming that I have an airtight syringe and an airtight jar, I'm not losing air particles when I squeeze it, and I'm not, gaining them back when I release it. So the mass also inside would be the same. So the number of air particles is still the same. That then means the mass of the air that's in there would still be the same. I know it's a very, very tiny amount, but it's still the same amount. Okay. Now, as far as what's the big difference between the two systems, or between the decreased volume and the increased volume, that has to do with density. All right. So density is the amount of matter in a certain volume. So I'm going to have you take your highlighter out and go ahead and highlight this. So the amount of matter in a certain volume just means how much stuff is in that volume. Okay? How much air particles are in that volume. So if something is considered, we're going to use these words a lot, like more dense, less dense. If something is more dense, it means that there is less space between your particles. All right, so it means they're more squished together and there's less space for them. If things are less dense, it means there is more space between your particles. They have more room to spread out. and so on. Okay. So if I go on to the next page here, I'm going to have you go ahead and just, for now, I just want you to go to a new page, and I'm going to have you write this title again up there at the top. And don't glue this in yet, because I want to explain what you're doing with all this here. So just write what I have up here at the top on a new page. Now I know that we didn't fill up all of your page on the previous one. That's fine. Okay. So now this is important when you are going to take this next sheet here, the gas and the syringe one. But before you glue this in, I want you to double check. You need to glue this up high enough so that you have these number of lines down at the bottom. So I need at least 1, 2, 3, 4, 5, 6. You need 6 lines, all right, underneath your picture. If you can't fit it because the paper's too big, go ahead and trim off a little bit. I wouldn't even care if you trimmed off the top that says gas in a syringe, or trimmed it right up to the end of the nozzle on the bottom of the syringe. You just need to go ahead and think I put scissors in your trays. So you can use the scissors to trim this piece of paper up a little bit. But otherwise, glue it up closest to the top as you can. And then again, make sure that you have room for 6 lines down here. So I'm going to have the teacher pause the video here so I can, until you guys get that glued in. Don't worry about the writing. I'll go through that myself here. All right. So again, this paper here should be glued all the way up towards the top. And what we're going to do is we're going to make a kind of a comparison chart between these two pictures. So pretty similar pictures as far as we've seen these kind of before. So this is the syringe when it's more, has much more volume and is expanded. But as far as the number of particles goes, if you wanted to count the dots, you could, and you could see that they're the same. This is the one where it's the volume is decreased. Okay. So here's what I'd like you to do is I want you to draw a line underneath, like this horizontal line right here that I'm going to highlight it in yellow, but you don't need to highlight it, but I'm just trying to make that straight line there. Okay. So make a line horizontal that goes underneath across the whole page. And then you're also going to make one vertically here that goes down, and then it's going to go all the way down, past those 6 lines. So you're separating this into 2 sides here. What we're going to do is put information under each of those. Okay. So as I pull this up, I want you to write down for each line, make sure they go in the same line here, right across from each other. And so in the first picture, I want us to note that they both have the same number of particles. Okay. So I don't want to count them right now, but it's maybe like 30. And hopefully they are the same. If they're not, they should be. It would just be an error, but same number of particles. So that has not changed. It looks like I'm dealing with an airtight system. Since the number of particles is the same, the mass would also be the same because the mass is coming from those particles. And remember, this is gas particles, so they do not stick together. They have space in between them. So they both have the same mass. So far those 2 things are the same, but now let's get into their differences. So as far as the volume goes, the volume is how much space they have inside the syringe. Now you can definitely see that the first picture has a larger volume, and the second picture has a smaller volume. This is going to create differences in pressure. Since the molecules in the first picture are more spread out, they are not creating as much of a pressure on each other and on the sides of the syringe and the back of the syringe, whereas the other molecules are very, very much compressed, increasing that pressure. We've talked about the motion of the particles. You obviously can't see it here because it's just a drawing, but the particles in the first picture would be moving slow, and the particles in the second picture would be moving faster. And the last thing to write down has to do with their density. So since the first picture has more space between the molecules and particles, that is less dense. And since the second picture has less space between the particles, that means it's more dense. So again, density is a measurement of how much mass, how much matter you have per unit volume. So if you have smaller volume but same mass, your density is going to be higher. All right, if you need to pause this to finish writing this down at all, you can do that. All right. So for the next page here, and actually this can go, nope, I gotta have this on a new page, sorry. Okay, so on the next page, go ahead and do our title up here again. So this should be our third time doing that today. And then you can write down those directions, read pages 32 through 40. Okay. So after you write this down, you may go get a book from the back of the room, the purple weather water books, and you can open that up and go ahead and do that reading. So I expect you to do this. I need you to spend at least 10 minutes on it. If you guys, if kids need to leave the room to read, that's fine. But you're going to make sure that you do that reading here. And so I'm going to have your teacher pause that video until most of you are done with the reading. Okay. So if you are done with the reading, or if this is just like the last 5 minutes or so of class, I want you to, this can be on the same page that you wrote the directions. Okay, so the same page that you wrote the directions for, read pages 32 through 40. Go ahead and write this right underneath that. Think questions, page 40. This does not need to be a new page. This can be right on that page that you wrote read. So go ahead and write think questions, page 40. And then this time I actually have a question sheet for you. that you should have in your tray, and you can go ahead and glue that in. And then your assignment for tomorrow is to finish the reading if you haven't done so already and answer these questions. So make sure that you write down in your planner that you need to do the reading if you need to finish it or answer these think questions. All right. I'm going to end the video here. Your teacher can keep this up for you if you need to, but just please make sure you write that down in your planner and try to get that done for tomorrow.